So what is ozone? It is the allotropic form of what? Oxygen. So ozone is an allotropic form of oxygen. Okay, it is an allotropic form of oxygen. It is an allotropic form of oxygen. It's an allotropic form of oxygen. It is an allotropic form of oxygen. Okay, present about 20 km from sea level. Present at 20 km from sea level. Okay, it protects the earth from which radiation? UV radiation. It protects the earth from UV radiation. Okay, it is a colorless, it has a characteristic smell. 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 Okay, pure ozone. That is, pure ozone is a pale blue gas. Dark blue liquid. Dark blue liquid or violet black solid. So in gaseous state, what is the color of pure ozone? Is a pale blue. And what is the color of liquid ozone? Dark blue. And what is the color of solid ozone? White black. Okay, pure ozone is a pale blue gas, dark blue liquid, violet black solid. Okay, it is prepared from, it is prepared by dry stream of O2, dry stream of O2 passing through an electrical arc. Passing through an electrical arc. Passing through an electrical arc. Electrical arc. Okay, so that means oxygen is passing through an electrical arc. You can prepare what? Ozone. So the process is endothermic or exothermic? The process is endothermic or exothermic? Endothermic. So which is stable, product or reactant is more stable? Reactant is more stable. So that means ozone is thermodynamically more unstable than oxygen. So it is more reactive than oxygen. Okay, that is. Okay, so ozone is thermodynamically more unstable than oxygen. Ozone is thermodynamically more unstable than oxygen. More unstable than oxygen. Unstable than oxygen. So it is more reactive than oxygen. So it is more reactive than oxygen. Okay, less soluble in water. Less soluble in water. Less soluble in water, but freely soluble in organic solvents. But freely soluble in organic solvents. But freely soluble in organic solvents. Freely soluble in organic solvents. Okay. And ozone. Ozone can also act as what? oxidizing agent, that is ozone is decomposed to give water O2 plus monoxygen. So ozone act as a oxidizing agent due to decomposes to give a nascent ozone can act as a oxidizing agent. Ozone can act as a oxidizing agent due to it decomposes to give monoxygen. Due to it decomposes to give monoxygen. Due to it decomposes to give monoxygen. Okay, so it can oxidize. It can oxidize C into CO2. So that is C plus 2O3 gives CO2 plus 2O2. Okay, how many monoxygen is required here? 2 monoxygen is required. So how many ozone is required here? 2O3. So it gives CO2 plus 2O2. Okay, and I2 into 2HiO3. So it is a mixture of water H2O plus I2O plus 5 monoxygen. Okay, so how many ozone is required? How many ozone is required? 5 ozone. So that is 5 I2 plus 5 ozone plus 1 H2O gives what? 2 HiO3 plus 5 O2. Okay, okay, 5 ozone. SO3 ഒന്നും കൊടുക്കില്ല. 5 ozone അല്ല, 5 ozone and 5 O2. Okay, so give the oxidizing action of P4 into H3PO4. P4 into H3PO4 and S8 into H2SO4, 8 and 4. Give the reaction. So 4H3PO4, that is a 6H2O plus P4 plus 16 plus that is 10 monoxygen. So the 6H2O gives 4H3PO4 plus 10 O2. Okay, and here also 8. So how many water? 8H2O plus S8 plus 32 and minus that is 26. 26 അല്ലല്ലോ, 32 8 പോയി കഴിഞ്ഞാൽ 24 അല്ലേ, 24 monoxygen. 24 O3 plus 8 H2O gives 8 H2SO4 plus 24 O2. Okay, so ozone can also act as what? Oxidizing agent due to it decomposes to give nascent oxygen. Oxidize 2Ag into Ag2O. So what is 2 plus and the same way it can and same way PbS into PbSO4, PbS into PbSO4, that is PbS plus 4O3 gives PbSO4 plus 4O2. Okay, KNO2, KNO2 is converted into KNO3, so that is KNO2 plus ozone gives. Okay, and the same way it can convert Ki into I2, that is potassium iodide into I2. Okay, so here that is 2 Ki plus H2O plus ozone gives 2 KOH plus I2 plus O2. These are the oxidizing action of ozone. So due to it oxidizing, what I mean by BOD and COD? What is BOD and COD? Biological oxygen demand and chemical oxygen demand. That means the demand of oxygen for sterilizing a particular amount of water. So that means for sterilization what we required is oxygen. So oxidizing agent can also act as water, bleaching agent. Okay, so due to its oxidizing action, ozone can also act as a bleaching agent. Due to its oxidizing action, it can act as a bleaching agent. Bracket it's a temporary one. Okay, so colored substances in water plus ozone gives O2 plus colorless water. போன கிளாஸ்ல இருந்தா போன வருஷம் இங்க இருந்தா okay. So what is our tropospheric pollution? What is tropospheric pollution? Ozone depletion. So ozone depletion by reaction action of what? Chlorofluorocarbons or CF2Cl2. By which mechanism? Free radical mechanism. So ozone depleted, ozone undergoes depletion. in presence of chlorofluorocarbons. In presence of chlorofluorocarbons. There is example CF2Cl2, that is Freon 12. CF2Cl2, chlorofluorocarbons by free radical mechanism. Okay, and the same way NO, nitric oxide, rapidly combines with water, ozone. That is, NO is rapidly combines with water, ozone. So gives water NO2 plus O2. So rocket, the exhaust system of rocket NO, releases water NO. So this combines with water, ozone. So what the process undergoes? Ozone depletion. Okay, good. NO can rapidly combines with the ozone. NO can rapidly combines with the ozone. NO can rapidly combines with the ozone. Okay, so nitric acid, that is NO plus O3 gives NO2 plus O2. Hence, the nitric oxide emitted from supersonic jet aeroplanes, nitric oxide emitted from supersonic jet aeroplanes depletes the ozone layer. Depletes the ozone layer. Depletes the ozone layer. Supersonic jet aeroplanes. Supersonic jet aeroplanes. Rocket jet aeroplanes. May depletes the ozone layer. Depletes the ozone layer. Okay, and ozone can titrate against what? Sodium thiosulfate solution. So that is a quantitative estimation of what? Ozone. Okay, so ozone can estimate titrated against, ozone can titrated against sodium thiosulfate solution. Sodium thiosulfate solution. Sodium thiosulfate solution. It is the quantitative estimation of ozone. It is the quantitative estimation of ozone. It is the quantitative estimation of ozone. It is a quantitative estimation of ozone. Okay, so ozone can be used as what? Sterilizing water angle is used as a bleaching agent. Okay, ozone can be used for sterilizing water and bleaching agent. Ozone can be used as a sterilizing water or as a bleaching agent. Bleaching agent. Okay, and the same way ozone is reacted with the alkenes or alkynes. They give corresponding ozonides. They give corresponding water ozonides. So what is reacting? CH2 is reacting with the ozone, gives CH2, that is oxygen and oxygen. Okay, and the same CH2. Okay, CH triple bond CH. Okay, plus ozone. It gives what? CH, oxygen and oxygen. So it gives the ozonides. This is ethylene ozonide and this acetylene ozonide. Okay, good. Ozone is reacted with the alkenes or ozone reacted with the alkenes or alkenes or alkynes gives corresponding ozonides. 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 Acetylene ozonide. Acetylene ozonide. There is a bond. There is a bond. Acetylene ozonide. Ozone. Okay. So what do you mean by ozone? Ozone is an allotropic form of oxygen. Okay, present at the troposphere and it protects the earth from UV radiations and it can be prepared by passing oxygen over electrical spark. The process is an endothermic process. So here oxygen is thermodynamically more stable than ozone. The same way ozone is more reactive than water. Oxygen. Okay, and it acts as a good oxidizing agent and it can also sterilize the water due to its bleaching action. Okay, ozone. Next one, allotropes of sulfur. 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 So what are the different types of allotropes of sulfur? Alpha sulfur or rhombic sulfur. Rhombic sulfur. And second one is beta sulfur or monoclinic sulfur. So what are the different types of allotropes of sulfur? Alpha sulfur and beta sulfur. So how alpha sulfur is prepared? Alpha sulfur is prepared by evaporating the solution of roll sulfur in CS2 solution. Roll sulfur solution in CS2 solution is evaporating, you will get water, alpha sulfur. And beta sulfur is formed from water, alpha sulfur. Okay, the first one is alpha sulfur. First one is alpha sulfur or rhombic sulfur. It is prepared by evaporating the solution of roll sulfur in CS2. Evaporating the solution of roll sulfur in CS2. Okay. Roll sulfur in CS2. Roll sulfur CS2 and it is soluble in water. CS2 not soluble in water. Soluble in CS2, not soluble in water. Sulfur, it is a polar or non-polar one? Non-polar. So it is not soluble in water but soluble in CS2. Okay, it is a yellow colored one. Yellow colored alpha sulfur. Okay. So how beta sulfur or monoclinic sulfur is formed? So beta sulfur is formed by melting water, alpha sulfur. Melting water, alpha sulfur in a particular dish. Okay, melting alpha sulfur is melting alpha sulfur in a dish. Okay, then just formed, that means just making a crust, a cake formation, but just a crust. Okay, two holes. So this is and crust. Okay, so a very light liquid which so all these liquids are in these holes. This removal of this crust will give needle shaped beta sulfur. So what will be the color of beta sulfur? Light yellow or dark yellow? Dark yellow or light yellow? After formation of a cake, the remaining light liquid poured into the holes and made what? Beta sulfur. Color dark yellow or light yellow? Light yellow. Okay, they are conformably soluble in water, CS2, due to its what nature? Non-polar nature. Of this contains mostly sulfur or water? Water. So it is in water due to it's a very light liquid. Okay, so beta sulfur is formed from water. It is formed by melting alpha sulfur in a dish. By melting alpha sulfur in a dish. By melting alpha sulfur in a dish. Melting alpha sulfur in a dish, and wait, a crust is formed. Wait, a crust is formed. Wait, a crust is formed. Then made 2 holes in it. 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 The remaining liquid is poured into these holes. The remaining liquids poured into these holes. Poured into these holes. After removal of the crust, after removal of the crust, after removal of the crust, needle shaped beta sulfur is formed. Needle shaped beta sulfur is formed. Beta sulfur is formed. Okay, needle shaped beta sulfur is formed. Next one. So what is the color? Will be light yellow. Light yellow. Light yellow. Light yellow. Light yellow. Soluble in water. Soluble in both H2O and CS2. Soluble in both. Okay, in both allotropic forms of sulfur, sulfur have what? S8 forms. So what is the shape of S8 form? What is the shape? Crown shape. Okay, so in each allotropic forms we have crown shaped S8 non-polar S8 molecules. In both allotropic forms, in both allotropic forms, in both allotropic forms we have a crown shape. S8 have a crown shape. S8 have a crown shape. S8 have a crown shape. Old ground, old ground. പഴയ കാലഘട്ടത്തിലെ ക്രൗൺ. ദാറ്റ് ഈസ് ചെറിയൊരു ക്രൗൺ മാതിരില്ലേ? Okay, in cyclo S6 there is angel sulfur or E sulfur. It's another allotrope of sulfur. Okay, cyclo S6 it has a what form? Chair form. What form? Chair form. Okay, up in cyclo S6, in cyclo S6 it has a chair form. In cyclo-S6 it has a chair form. In cyclo-S6 it has a chair form. Okay, chair form. Okay, chair. Is angel sulfur എന്നൊക്കെ പറയും. ഈ സൾഫർ ഏഞ്ചൽ സൾഫർ അല്ലേ? ഇറ്റ് ഇസ് another allotrope of sulfur. Okay, okay. So this is alpha sulfur and beta sulfur. Okay, so temperature is greater than 369 Kelvin. Alpha sulfur converted into water, beta sulfur. And the same way, temperature is lower than 369 Kelvin. Okay, beta sulfur converted into water, alpha sulfur. That means alpha sulfur is stable below 369 Kelvin and beta sulfur is stable above 369 Kelvin. So that means at 369 Kelvin the both allotropic forms are coexist. Okay, alpha sulfur is stable below 369 Kelvin. Alpha sulfur is stable below 369 Kelvin. Below 369 Kelvin. Below 369 Kelvin. And beta sulfur is stable above 369 Kelvin. Above 369 Kelvin. Above 369 Kelvin. That is at 369 both allotropic forms are exist together. Both allotropic forms are exist together. Okay, so at what temperature one form of an allotropic form is converted into another form? 369 Kelvin. So what is the transition temperature? Means the temperature at which one form is converted into another temperature. So what is the transition temperature here? 369 Kelvin. Okay, ozone, allotropes of sulfur, oxygen. Okay, so 369 is the transition temperature for alpha and beta sulfur. And here oxo acids of sulfur. Oxo acids of sulfur. Oxo acids of sulfur. So what is H2SO3? Sulfurous acid. What is H2SO4? Sulfuric acid. Okay. What is SO5? What is H2SO5? Kerose acid. So simply it is a peroxomonosulfuric acid. It is peroxomonosulfuric acid. What is H2SO6? It is the dithionic acid. Dithionic acid. And H2SO7 is a pyrosulfuric acid. Pyrosulfuric acid. It is simply water. Simply water oleum. And H2SO8 is the peroxodisulfuric acid. Peroxodisulfuric acid is simply Marshall's acid. Okay, so kerose acid, oleum, Marshall's acid, H2SO3 and H2SO4, sulfurous and sulfuric acid. Okay. pyrosulfuric, peroxodisulfuric, dithionic, peroxomonosulfuric, sulfuric acid, sulfurous acid. Okay. Okay. So these are the oxo acids of sulfur. So what is kerose acid? H2SO5. What is oleum? H2S2O7. What is Marshall's acid? So what is other name? Peroxodisulfuric acid. So what is peroxomonosulfuric acid? H2SO5. What is peroxodisulfuric acid? H2S2O8. Okay. 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 H2SO3. H2SO3. Sulfur with Mundane oxygen. Okay. How many hydrogen? 2 hydrogen. How many remaining oxygen? 2 oxygen. So if 1 oxygen is here, okay, 1 oxygen is here and 1 oxygen is here, and there will be a lone pair of electrons. Okay, and the same way, what is H2SO4? Sulfur with Mundane oxygen and 2 hydrogen. How many oxygen is remaining? 3. So that is 2 here and 1 here. Okay, and next one is H2SO5. H2SO5, sulfur with the Mundane oxygen and 2 hydrogen. How many oxygens are remaining? 4 oxygens, the 1 and 2. And how many oxygens are remaining here? 2 oxygen. So what is the valency we have? 2 valency, that is 1, 2, 3, 4, 5 and 6. This is the maximum valence electrons. So here we are giving an oxygen and this oxygen is between here. Okay, so H2SO5. And next one is H2S2O6, 2 sulfur with the Mundane oxygen. Okay, 2 hydrogen, 1 for this sulfur and 1 for this sulfur. How many oxygens are remaining here? 4 and 1 and 1. Then how many oxygens are remaining? 2. 1 for this sulfur and 1 for this sulfur. Okay, H2S2O6. So what will be the structure? That is a dithionic acid. Dithionic acid. So what is the structure of H2S4O6? That means thionic acid. Okay, that is a OH. Tetrathionic acid. So what is polythionic acid will be? S. Okay, so what is the oxidation state of sulfur here? -2 and -1. This is +5. Okay, this is 0, this is 0 and this is a +5. Okay, and next one is H2S2O7 with the, and how many hydrogens? 2 hydrogen, 1 for this sulfur, 1 for this sulfur. Okay, and how many oxygen is remaining? 5. 1 here, 1 here. How many remaining? 3. So 1 for this sulfur and 1 for this sulfur and 1 for both. Okay, H2S2O8. H2S2O8. Sulfur, Mundane oxygen and 2 hydrogen, 1 here and 1 here. How many oxygen is remaining? 6. 1 here and 1 here. How many remaining? 4. So 1 here and 1 here and there is 2 here. Okay, that means 1, 2, 3, 4, 5, 6. Maximum valency is 6. Okay, so which of the oxo acid of sulfur contains lone pair of electrons? Which of the oxo acids contains peroxide linkage? Peroxodisulfuric acid, peroxomonosulfuric acid, dithionic acid, tetrathionic acid. Okay, the same way this is oleum. Okay. Good. Again, sulfurous acid, sulfuric acid, peroxide monosulfuric acid, dithionic acid, tetrathionic acid, oleum and peroxide disulfuric acid. Okay, appo first one important one H2SO4. H2SO4, sulfuric acid. Sulfuric acid. Sulfuric acid. So what is the commercial preparation of sulfuric acid? Contact process. The commercial preparation of sulfuric acid is a contact process. Good. Commercial preparation of a sulfuric acid is a contact process. H2SO4, sulfuric acid preparation by which process? Contact process. Okay, it involves 3 steps. It involves 3 steps. It involves 3 steps. First step, burning of water, sulfur or sulfide ore or sulfide ore. Okay, so burning of sulfur or sulfide ore gives what? SO2. And what will be the second? Second step, SO2 is a catalytic oxidation of SO2 into water. SO3, catalytic oxidation of SO2 into water, SO3. So what is the catalyst? Catalyst used in contact and SO3 is absorbed by water. SO3 is absorbed by water. So it gives water H2S2O7. That is SO3 is reacted with H2. Next one. SO3 is reacted with the water. Gives water H2SO4. But here this H2SO4 is a dense fumes of H2SO4. It is a dense fumes of H2SO4 and it is difficulty to condense into liquid state. Okay, so here we are using SO3 is absorbed by water, H2SO4 gives water H2S2O7, that is oleum. Okay, and here this oleum on hydrolysis. Oleum on hydrolysis gives water desired concentration of sulfuric acid. Okay, so here we are noting SO3 is absorbed into the formation. It is a dense fumes of H2SO4 and difficulty for condensation. Difficulty for condensation. So what is the first step? Burning sulfur or sulfide ore gives what? SO2. What is the second step? Catalytic oxidation of SO2 gives SO3. And third step, SO3 is absorbed by H2SO4 gives oleum. Then it on hydrolysis gives a desired concentration of sulfuric acid. First step, burning of sulfur or sulfide ore. Burning of sulfur or sulfide ore. Burning of sulfur or sulfide ore. Burning of sulfide or sulfide, sulfur or sulfide ore. Okay, give the reaction. S plus O2 gives SO2 or FeS2 plus O2 gives Fe2O3 and SO2. Second step, catalytic oxidation of SO2 into SO3. 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 Okay, that is 2SO2 plus O2 gives 2SO3 in the presence of vanadium pentoxide. Okay, next one is SO3 absorbed by H2SO4. SO3 absorbed by H2SO4. SO3 absorbed by H2SO4 gives oleum. Gives oleum. Then it on hydrolysis gives. Desired concentration of H2SO4. Desired concentration of bracket 96 to 98%. 96 to 98%. Okay, the preparation of sulfuric acid contact process involve 3 steps. Okay, settle. Next one. Okay, first one burner. First burner. First step in the burning sulfur. Burner in the presence of water. Oxygen. So here we have water, sulfur, and sulfur. So what is this? Sulfur. Okay, so burning sulfur you will get to water SO2 plus O2. SO2 and with some amount of oxygen also. So it is a burned one. So we have to remove the ashes. Ash remove cheyande. So first into a precipitator for the removal of any ashes or solid contents. Okay, then after washing tower അല്ലെങ്കിൽ cooler. Washing tower. This is washing tower. Washing tower, that means spraying water H2O, spraying water H2O. Okay, so here the acid impure acid, impure water, acid impure water. So you will get water moist SO2 plus O2. First burn cheya. Then in the precipitator for the removal of any solid contents. Then pin in the wash. Okay, complete and cleaned. Completely cleaned. But it is a moist SO2 and O2. What is the second process? Catalytic oxidation. Okay, so we require water, dry SO2 and O2. So next is a dryer. Okay, dryer. So this is dryer. What is a good drying agent? H2SO4. Okay, so this is remaining impure acids comes. So what is the product here? Dry SO2 plus, and for the final process it passing through a arsenic purifier. It passing through a arsenic purifier which contains gelatinous precipitate of FeOH thrice and converted into a preheater. Okay, then a absorption tower. Okay, like catalyst column. So what is here? V2 of M. Okay, so what is the first process? Burning sulfur. Second process, oxidation of SO2 into SO3. But first removal of the solid content, then washing, then drying, and just passing through a purifier for the removal of any impurities, and just preheated. This is a moist low temperature one. Okay, just preheats and comes into catalyst column, contains what? Vanadium pentoxide. So what come here? SO3, and SO3 next goes to into absorption tower, which contains what? H2SO4, and here you will get what? H2S2O7, that is oleum. Okay, and H2S2 oleum on hydrolysis gives what? Corresponding desired concentration of H2SO4. The plant is operated at 720 Kelvin and 2 bar pressure. Okay, good. Industrial preparation. Burner, simple. Burner, removal, drying, purifier, catalyst column, and absorption tower. The symbol, the symbol. അല്ല അല്ലേ? ഞങ്ങൾക്ക് 34 ആയിരുന്നു. 34 ചാർട്ട്സ് അല്ലെങ്കിൽ இந்த மாதிரி இருக்கிற 34 ப்ராசஸோட கம்ப்ளீட்டு இது படிக்கணும் கெமிக்கல் இன்ஜினியரிங்கில். ஃபுல் எல்லாம் படித்ததுக்கப்புறம் ஒன்று தான் கேட்பேன் எக்ஸாமுக்கு இதுக்காக அல்ல. நீங்கள் கரெக்டாக கொடுத்துருங்க. நான் இல்லை நல்லா அவருக்கு இல்லை നൈസായിട്ട് വരച്ചോളൂ. വേസ്റ്റ് വാട്ടർ, വേസ്റ്റ് ആസിഡ്, ഇംപ്യൂർ വാട്ടറിൽ വേസ്റ്റ് വാട്ടർ അല്ല, വേസ്റ്റ് ആസിഡ്. ബർണർ, വാഷിംഗ് ടവർ, ഡ്രയർ, ആർസനിക് പ്യൂരിഫയർ, പ്രീ ഹീറ്റർ, കാറ്റലിസ്റ്റ് കോളം, അബ്സോർപ്ഷൻ ടവർ അല്ല. ഫൈനൽ വലിയ സെറ്റായ അല്ലേ? ബേണർ വിച്ച് ബേൺ ദി സൾഫർ ഇൻ ടു SO2 അല്ലേ? വാഷിംഗ് ടവർ വാഷസ്, ഡ്രൈയിങ് ടവർ ഡ്രൈസ് അല്ലേ? വി വിൽ ഗെറ്റ് ഡ്രൈ SO2 and arsenic purifier. Just preheat the catalyst column, give SO3 is absorbed by H2SO4 gives അല്ലേ? ഞാനവിടെ എഴുതി സ്ഥലമില്ലാത്തതുകൊണ്ടല്ലേ എടേ ഇങ്ങ സ്ഥലം കിടക്ക நான் இது இங்கே கொடுத்துருக்கேன் அல்ல, உங்களுக்கு സ്ഥലം இருக்குമ്പോൾ அங்கேயே கொடுக்கும். இது கரெக்டாയിട്ട് എഴുതി അത് മുകളിലുണ്ട് അല്ലേ? പക്കാ കോപ്പിയടി അല്ലേ? നല്ല നല്ല ഗുഡ് அப்பா கடவுளே. நேற்று நைட்டு எனக்கு பெஸ்ட் டே. நாங்கள் கரண்டே இருந்தில்ல ஹோட்டலில். பெஸ்ட் டே. 1 மணிக்கு அவரை வந்து ரூமு சேஞ்ச் பண்ணி தந்தோம். அங்கே கரண்ட் வரே போகிறேன் ஏசி ஓனாவரோ ஓஃப் ஆகிறேன். ஐயோ 1 மணிக்கு அவர் வந்து அவரே ஸ்டே பண்ணுற ரூம் எல்லாம் க்ளீன் பண்ணி நீங்கள் இங்கே கிடக்கு. அந்த அளவுக்கு நைஸ் ஏசி கிடச்சிருச்சு, நல்ல ஏசி. ஐயோ சிட்டாயா ഓക്കെ. അപ്പോൾ പ്രോപ്പർട്ടീസ്, സൾഫ്യൂരിക് ആസിഡ് പ്രോപ്പർട്ടീസ് മക്കളെ. ലിക്വിഡ് ഗ്യാസിഡ് ഓർ സോളിഡ്? ലിക്വിഡ് ഗ്യാസിഡ് ഓർ സോളിഡ്? ലിക്വിഡ്. കളർലെസ് ലിക്വിഡ്. പ്രോപ്പർട്ടീസ് കളർലെസ് ലിക്വിഡ്. Properties colorless liquid alle. They also called what? H2SO4 is also called what? Oil of vitriol. Also called what? Oil of vitriol. Good. Sulfuric acid is also called sulfuric acid. La oil of vitriol alle. It is also called oil of vitriol alle. Okay alle. What about the viscosity? High viscosity or low viscosity? High viscosity. Ara low solle kalla paduvati nokkiya. Low or high? High viscosity. Dense liquid. Viscosity is opposite to what? Fluidity. High viscosity means low fluidity. Water and oil which have higher fluidity, water which have higher viscosity. So dense liquid. What about the viscosity? High. What about the solubility of H2SO4 in water? Low, very low. H2SO4. Add water, dilute H2SO4. Add water, dilute H2SO4. So what about the solubility? High allada. High alle. So high viscosity and solubility due to presence of which bond? Hydrogen bond. High solubility, high viscosity due to the presence of hydrogen bond. What about the acidic nature? Strongly acidic or weakly acidic? Strongly acidic in nature. Strongly acidic in nature. Okay, so it ionizes in single step or double step? It ionizes in single step or double step? എത്രയാ? സിംഗിൾ 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 അല്ലേ? SO4 2 minus അല്ല, HNO3 is ionizes in a single step and H2SO4 is ionizes in a double step. So what is the dissociation constant Ka1 and the dissociation constant Ka2? Which will be higher, Ka1 or Ka2? Ka1 or Ka2? Ka1 will be greater than Ka2. What about the dissociation constant value if it is high? What is the value of Ka1 will be, അല്ലെങ്കിൽ dissociation constant will be high or low? High or low? High or low? High? 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 High. Dissociation. Dissociated to give what? H plus. So dissociation constant increases, acidic nature increases. H2SO4 is highly acidic. So what about the dissociation constant value will be very high. Okay. So why H2SO4 is strongly acidic in nature? Due to it has a high dissociation constant. Okay. It ionizes in 2 step. It ionizes in a 2 step. അപ്പോൾ ഇങ്ങനെ ഡിഫറെന്റ് ടൈപ്സ് ഓഫ് സൾഫേറ്റ് NaOH combines with here gives what? Na2SO4 combines with here comes what? NaHSO4. So H2SO4 can gives normal sulfate and hydrogen sulfate due to it ionizes in a 2 step. Due to there is a presence of what? Normal sulfate ion and hydrogen sulfate ion. Okay, so it gives normal sulfate and hydrogen sulfate. So it can give normal sulfate and hydrogen sulfite. Normal sulfate and hydrogen sulfate, Na2SO4 and NaHSO4. Okay, H2SO4 oxidizing acid or non-oxidizing acid? Oxidizing. So H2SO4 can act as a good what? Oxidizing agent. Due to it decomposes to give what? Nascent oxide. So H2SO4 act as a good oxidizing agent. H2SO4 act as a good oxidizing agent. H2SO4 act as a good oxidizing agent. Due to it decomposes to give nascent oxygen. So C into CO2. So that is C plus 2H2SO4 gives CO2 plus 2H2O plus 2SO2. Okay, അതേപോലെ തന്നെ it can oxidize P4 into what? P4 O10. Okay, so what is P4 plus 20 H2SO4 അല്ലേ? ഇവിടെ H2SO4 1 അപ്പോൾ 2. ഓക്കെ, അപ്പോൾ 1 H2SO4 അപ്പോൾ 10 അല്ലേ? 10 H2SO4 പോരാ, 10 H2SO4 gives what? P4 O10 plus 10 H2O plus 10 SO2. Okay, and the same way it can oxidize S8 into what? SO2. S8 into what? SO2. So here how many oxygen is remaining here? 16. So what is S8 plus 16 H2 SO4 gives 8 SO2 plus here 16 H2O 16 H2O plus 16 SO2 16 SO2. So basically how many SO2? Okay, S8 converted into what? SO2, and H2SO4 is also decomposed to give what? SO2. So forms what? 24 SO2. Okay. So H2SO4 is also act as a oxidizing agent. So H2SO4 act as a good bleaching agent. Is H2SO4 is a good bleaching agent? No. What do you mean by bleaching agent? Used for sterilizing water. Sterilizing water by adding acid, sulfuric acid. Is it a normal process? Ozone passing through normal water, it gives sterilized water. We can drink the water. There is a water, sterilizing water by adding water, H2SO4. Add more and more H2SO4. Water will be sterilized. Is it good for drinking? So H2SO4, HNO3 are good oxidizing agent, but they are not act as good bleaching agent. Okay, so bleaching agent they are used for sterilizing water. Okay, next one H2SO4. It is less volatile. Less volatile. H2SO4 is less volatile. Less volatile. So what do you mean by volatile? Vaporizable. So it is high. So what about the volatile nature will be very low, and due to its less volatile nature, it is used to make volatile acids. It is used to make volatile acids. So it is used to make what? Volatile acids. So MX, metal halide, reacted with what? H2SO4 gives metal sulfate and what? HX. So that is HF and HCl. HF and HCl are volatile acids. Okay, what is that? Okay, X, Br and iodine. If X is equal to what? Br and iodine. They oxidizes to give what? They oxidizes to give Br2 and I2. Okay, so what is the charge here? -1. What is the charge here? -1. So they do not undergoes what? Oxidation or reduction for halogens. But if it is bromine or iodine, they undergoes what? Oxidation, and they gives what? Br2 and I2. So if it is 2NaBr, 2NaBr is reacted with H2SO4 gives what? Br2. Okay, it gives what? Br2 and Na2SO4 plus H2. Okay, and the same way HBr or HI. So they also reacted with H2SO4 gives corresponding what? Br2 and I2. Okay, what is that? If it is a metal halide, is a fluorine or a chlorine, they converted into what? Their corresponding hydrohalous. Okay, but here if it is Br or iodine, they converted into what? Br2 and I2. Okay, it decomposes the carbon and carbonates. It decomposes what? Carbonates and bicarbonates like Na2CO3 plus H2SO4. Okay, so it gives what? Na2SO4 plus what? H2O plus what? CO2. And the same way bicarbonate reacted with what? H2SO4 is again what? Na2SO4 plus what? 2H2O plus what? CO2. Okay, let's do. So here carbonates and bicarbonate are decomposed to give what? Liberate CO2. Okay, it decomposes the carbonates and bicarbonates. It decomposes the carbonates and bicarbonates and liberate CO2. It decomposes the carbonates and bicarbonates, liberate CO2. Okay, that is okay. അതേപോലെ തന്നെ ആക്റ്റീവ് മെറ്റൽസ് reacted with H2SO4. What happens? It is a strongly acidic in nature, so metal get Metals dissolved in H2SO4. So gives what? ZnSO4 and liberate what? H2. Active metals dissolves in H2SO4 and liberate what? H2. Cu plus H2SO4 gives CuSO4 plus H2. Active metals dissolves in H2SO4 and liberate H2. நிறைய ரியாக்ஷன் பார்த்ததுக்கப்புறம் இப்போ ஒரு ரியாக்டன்ட் கிடைச்சா இல்லை ஆல்மோஸ்ட் ஏது ப்ராடக்ட் വരുന്നൊരു ഐഡിയ இருக்குல்ல അതേപോലെ അല്ലേ ഇടിയാ അതേപോലെ തന്നെ which is the strongest dehydrating agent? H2SO4. So it acts as a good H2SO4 acts as a good dehydrating agent. H2SO4 act as a good dehydrating agent. H2SO4 is act as a good dehydrating agent. All 12 carbon plus 11 H2. This process is called what? This process is called what? Charring. 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 Removing water. Charring. അതേപോലെ തന്നെ HCOH treated with concentrated H2SO4 gives what? CO plus H2. What is CO plus H2? Water gas. Dehydration with formic acid. Okay അല്ലേ? H2. Again, dehydration formic acid. അതേപോലെ ഓക്സാലിക് ആസിഡ് it is H2O plus CO plus CO2 oxalic acid.
Endothermic reaction, electric arc, endothermic reaction stable. O2
passing through electrical arc. What do you mean by electrical arc? You are giving heat or taking heat? Giving heat. Process is endothermic. What do you mean by endothermic and exothermic processes? Endothermic means heat is absorbed. That means delta H is positive. That means this is a process. Heat is absorbed. So delta H is positive. Exothermic means heat is evolved. So O2 is converted into O3. Oxygen is converted into what? Ozone. So giving an electrical giving heat or taking heat? Giving heat. The process is endothermic. Okay. what do you mean by ozone? What do you mean by ozone? It is an allotrope of oxygen. Present where? 20 kilometer അല്ലെങ്കിൽ സിംപ്ലി ട്രോപ്പോസ്ഫിയർ അല്ലേ? ട്രോപ്പോസ്ഫിയർ ആണ്. ട്രോപ്പോസ്ഫിയർ ആണ് 20 കിലോമീറ്റർ ട്രോപ്പോസ്ഫിയർ. അത് ശരിക്കും 20 കിലോമീറ്റർ 0 to 11 കിലോമീറ്റർ ആണ് സ്ട്രാറ്റോസ്ഫിയർ. അത് കഴിഞ്ഞാൽ ട്രോപ്പോസ്ഫിയർ. ഓക്കെ, ട്രോപ്പോസ്ഫിയർ. ആൻഡ് ഇറ്റ് പ്രൊട്ടക്ട്സ് ദ എർത്ത് ഫ്രം UV radiations, and it is a preparation done by passing electrical arc through oxygen. That means a direct stream of oxygen. The process is so thermodynamically which is more unstable, so which is more reactive. Ozone can act as which agent? Due to it decomposes to give water, so it converts C into I2 into S8 into H2SO4, P4 into Ag into Hg into HgO, etc. Okay, and ozone depletion is done by the reaction of chlorofluorocarbon. By which mechanism? And NO is also rapidly combined with water, oxygen. So the nitric oxides emitted from jet airplanes may deplete the ozone layer. Okay, so ozone is used as what is the uses of ozone? It acts as a bleaching agent due to its oxidizing action. So they can be used for sterilizing water. It is a temporary action or a permanent action? It is a temporary action. Okay, and next one is allotropes of sulfur. What are the different types of allotropes of sulfur? Alpha sulfur and beta sulfur. Alpha sulfur is formed from roll sulfur. Okay, beta sulfur is formed from alpha sulfur, which is yellow in color. Alpha. Beta sulfur is light yellow or colorless. Light yellow or colorless. And alpha sulfur is stable above or below 369 Kelvin. Below 3. So what is the transition temperature for sulfur? 369 Kelvin. So above 369 Kelvin, which will be stable? Beta sulfur. So at 369, both of them will be coexist. That means they are existing in equilibrium. Okay, and in both the form site have what shape? Crown shape. It is non-polar or polar? So they are not soluble in water. So alpha sulfur is not soluble in water and soluble in but beta sulfur is soluble in both H2O and CS2. In cyclohexyl or angel sulfur or E sulfur, the S6 have which shape? Chair form. What are the different oxo acids of sulfur? Sulfurous, sulfuric, and peroxomonosulfuric, and dithionic acid, and pyrosulfuric or oleum, and peroxodisulfuric acid. So which of the oxo acid contains a lone pair of electrons? H2SO3. Which of the oxo acid contains peroxide linkage? H2SO5 and H2S2O8. Okay, different types of oxo acids. And what is the commercial preparation of H2SO4? What are the steps involved here? Burning of sulfur or sulfide ore into SO2. And next one is catalytic oxidation of SO2 into SO3. SO3 is absorbed into SO4. Gives what? Oleum. Okay, oleum on hydrolysis gives H2SO4. The plant is operated at 720 Kelvin and 2 bar pressure. So what is the normal concentration of sulfuric acid? Is 96 to 98%. Okay, and H2SO4, what is the property of H2SO4? It is a volatile or less volatile? Less volatile. So it is used to make volatile acids like HF and HCl. If it is Br or I2, they undergoes what? Oxidation. Gives what? Br2 and F2. It ionizes in 2 steps. So they can give what? Normal sulfates and bisulfate. They are strongly acidic in nature. So they can dissolve mostly in the active metals. Okay. Next, it acts as a good what agent? Oxidizing agent. Due to it decomposes to give nascent oxygen, and it acts as a good dehydrating agent. That means strong affinity for water. Okay. So these are the properties of sulfuric acid.